So I'm not going to go in detail with the first introduction. Okay, so all the discoveries, there's the introduction of cathode ray tube, isn't it? When the gas discharge, when the discharge tube was maintained, when the gas in the discharge tube was maintained at a different pressure, what are the observation made and what were the conclusion? So it was found that at sufficiently low pressure, this is about this one, discharge tube. So what happened when the gas tube was filled with some gases and the pressure became very low? When the pressure of the gas was about 0.01 millimeter of mercury, what happened? Very high potential difference is maintained, and it's a cathode and anode. Some particles will not be seen, but they observed some kind of scintillation near the anode, isn't it? Scintillation. Why? What is the reason for the scintillation? Green glow was observed. So the cause of this fluorescence was attributed to the
production
radiation, cathode rays, radiation which appeared to be coming from the cathode. So cathode rays were discovered. So we have to tell all this to the children. Immediately don't start with photoelectric effect. Please, whatever given in the book, no, we have to tell. We have to give the knowledge to the children. So this particularly, this discovery of cathode rays introduction should be given. Okay, 1870 by William Crook and 1879 suggested that these rays consist of stream of fast-moving negatively charged particles. All of us know that J.J. Thomson confirmed this hypothesis. We know only by name J.J. Thomson discovered electron. So behind his discovery, so many works were performed by different scientists. Experiment using discharge tubes were conducted by Crook and many other scientists. Okay, so by applying mutually perpendicular electric and magnetic field across the discharge tube, J.J. Thomson was the first to determine specific charge, that is E by M of the cathode ray particle. Okay, and all this. So you have to tell about emission of electron. So what are the different ways by which a metal can emit electron?
Thermionic emission, field emission, photoelectric
emission. Okay, so by different method, electron can come out of the metal surface. Okay, so by thermionic emission or photoelectric emission or electric field emission. Okay,
secondary electron
by X-ray.
Yes.
Okay, secondary electrons are by Coolidge tube. X-rays were discovered, isn't it? When secondary electron. That is there.
4 methods.
4 methods. What is the fourth method? What is the fourth method? Heat, electric field, light, and fast-moving electron can cause electron emission, isn't it?
Yes, ma'am.
Electron can cause electron emission. So these observations thus establish that though the way the electrons are emitted are different, were all identical. The particles which were coming out were identical. So J.J. Thomson named these particles as electron and suggested that they were fundamental universal constituent of matter. So he was awarded Nobel Prize in 1906 and 1913. The American physicist Millikan performed oil drop experiment to find out, to measure the charge on an electron. So E by M was discovered by J.J. Thomson, and charge was discovered by the value of the charge was discovered by Millikan. So mass of the electron was discovered. Okay, mass by knowing the ratio of E by M and E, specific mass of the electron could be determined. Okay. So there are free electrons in the metal surface. The free electrons are held inside the metal surface by attractive force. All the metals have 1 or 2 free electrons. So you have to supply energy in order to make the electron come out of the metal surface. That is only called as electron work function, isn't it? The minimum energy required by an electron to escape from the metal surface is called work function. It is generally denoted by phi naught and is measured by electron volt. So if you consider sodium electronic configuration is 281 and 2 electron in the first shell, 8 electron in the second shell. This electron is free electron, 281, but this 1 electron is bound. So you take this ion, no, sodium ion and an electron. Sodium can be considered as sodium ion and electron, and it is bound. The electron is bound to this free electron is bound to the atom. So you have to supply energy in order to make the electron come out of the metal surface. Please define electron volt too. So what is 1 electron volt? Suppose if you accelerate an electron, if you apply a potential difference, if an electron is subjected to a potential of 1 volt, the energy acquired by the electron is 1 electron volt. Okay, 1.602 into 10 power minus 19 joules. Okay, and on what factor work function depend? It is a property of the metal. Work function depends on the property of the metal and the nature of its surface. So these are the work function of different metal. From cesium to all alkali metals are photosensitive. So you can easily remove. See, the work function is less. Whereas platinum, it is the highest. So you can discuss about, I'm not going to do that. The evidence for photoelectric emission, first it was discovered by Hertz. In his electromagnetic wave experiment, we teach that Hertz experiment, isn't it? Do we?
Yes,
This year it is not there, but we tell them how Hertz produce electromagnetic waves. That you have to tell. And one more thing, Hallwalk and Lenard experiment. Hallwalk and Lenard experiment. He conducted a series of experiments with a discharge tube. So when photons or when light is incident on the cathode, so you have to apply a potential difference here. When light of suitable frequency is incident on the cathode, electrons were emitted. So the photoelectric current was recorded by the ammeter here. Okay.
It's called photoelectric effect.
Photoelectric effect. Yeah. So Hallwalk and Lenard observations investigated the phenomena of photoelectric effect. Lenard observed that when the ultraviolet radiation were allowed to fall on the emitter plate of an evacuated glass tube enclosing 2 electrode, current flows in the circuit. Okay, so this is these are the initial experiments performed in order to understand photoelectric effect. Okay, and they also studied how photoelectric effect depend on the intensity of light, frequency of light, and also anode potential difference between anode and cathode. Isn't it? So this is a discharge tube. Basically, this was the discharge tube used. And it is what is the main only difference is that here you will have a gate for the light to fall. So actually this, I think I have this, yeah. So you should have one window for the light to fall on the cathode. It's a photosensitive plate and you have a cathode. So evacuated glass tube. So why evacuated glass tube? Why we should evacuate the glass tube?
Gas will ionize by the gas.
Yes. Electron energy will get toward the gas molecule, the gas atoms of the gas will get ionized, and the energy of the electron will get lowered by when the electron bombard the ions. So the energy of the electron will be lower. They will not be able to reach the collector plate. So very good answer. Okay. Now, and intensity of radiation, sometimes this question is asked. What is intensity of radiation? This is the exact definition given in the reader. It's a number of energy quanta. Number of energy quanta emitted per second per unit area. That's why it is given as watt per meter square. Number means don't think that it has no unit. Number of energy quanta. So this number of energy quanta will have energy joule emitted per second per unit area. So joule per second is watt per meter square. This is a unit of intensity. So what were the variation here? The setup. This setup. What were the parameters that were varied? First experiment. What was the first varying parameter? Intensity was changed, isn't it? How to change the intensity? Am I audible, participants?
Some disturbance.
Disturbance is there, but now I think
Now
this one, some participant. Okay. When you are not talking, please unmute it, mute your thing. Okay. So now the intensity of light was varied. Maybe the source can be kept at different distance or different power bulb. Suppose if you are using a sodium vapor lamp, you can use a 100 watt or 200 watt or 60 watt. So in that way, you can vary the intensity. So you vary the intensity of the source and you measure the photoelectric current. That is a first experiment. So what was the result? What was the result? So this was the result, isn't it? Effect of intensity. So as intensity of light was varied, the photoelectric current also increased. This is for a particular, you are not changing anything, for a particular color or frequency of light. Okay. So here, the number of photoelectron emitted per second is proportional to photoelectric current is. So photoelectric current is more means what number of photoelectron emitted per second is more. It is proportional to the intensity. Now next one is what we do for the next one. We don't change the intensity, but we gradually increase the anode potential, isn't it? The potential difference between the anode and the cathode is increased. So what happens? So in this, so you have the light which is incident on the cathode, and you have a high voltage applied here. Now I am changing this voltage. The voltage is increased gradually. The voltage becomes, say, starting from 60 volt, it becomes 100, 120, 140, 160. So as the voltage increases, this is minus, this is plus. So the photoelectrons travel. Okay. So suppose and intensity is fixed. I'm not changing the intensity. For a constant intensity, the number of photoelectron incident on the photosensitive surface is constant. So initially the photoelectric current increases and attains saturation. It attains saturation. Now with respect to cathode, I'm making this as negative. What will happen? What is happening now? On the y-axis photoelectric current, isn't it? So I'm making it as more and more negative. What will happen? The electron will be repelled, na?
Photo current comes to stop.
Photoelectric current decreases, and then at a particular voltage, particular negative voltage, this is positive voltage, this is negative voltage. Okay. What happens to the current? The photoelectric current becomes zero. This is called stopping potential. Okay. So now the electrons which are ejected from the cathode, okay, they are attracted now. So if when this collector plate, I call this as a collector plate because it attracts the electron. When this becomes more and more negative, less number of electron, but some electrons are able to reach because they have kinetic energy, irrespective of the, despite the negative potential here, the electron which are having kinetic energy are attracted. So there is a current. But what happens is at a particular negative potential called stopping potential, at a particular potential, all the electrons are stopped. Even the maximum kinetic energy electrons are stopped. Okay. So at the stopping potential, the maximum kinetic energy electrons are stopped. Okay. So how do you define stopping potential? How do you define stopping potential? It is a minimum negative potential of the collector plate at which photoelectric current becomes zero, or the photoelectric current becomes zero when maximum kinetic energy electrons
energy of photoelectron becomes zero.
What type of electrons are stopped? The electron which are having maximum kinetic energy are stopped at stopping potential. Okay, that point should be clear, because when we define V0 as a stopping potential, what is the maximum kinetic energy? V0 is a stopping potential. What is maximum kinetic energy?
EV0.
EV0. EV0. Okay. So now when you consider what happens is when light is incident, suppose light is incident on the surface. So electrons are ejected. This is h nu and electrons are ejected. Or all the electron comes with the same kinetic energy? Do you think all the electrons are coming with the same kinetic energy?
No, ma'am.
Why electrons are coming out different kinetic energy?
Depend on the observation of incident radiation.
Incident radiation same only, no? Incident radiation is same only, isn't it? So this is a surface, let us say. This is a metal surface. Okay. Okay, now light is incident, let us say. Light of certain frequency and intensity. I'm not changing that. But now, so I am 3 photons are incident. So 3 electrons are coming out. It eject 3 electron. 1 photon eject 1 electron. Do you think that all this electron will be having the same energy? If they all of them have the same energy, then you won't get this graph now. This graph won't be there, isn't it? Correct? This part of the graph will not be present, isn't it?
Yes.
Because electrons, see, electrons which are having low kinetic energy are stopped. Electrons which are having higher kinetic energy can reach the collector plate. Because they have high kinetic energy, they are able to overcome the retarding potential. That is called retarding potential. Because electrons are negative, the collector plate is also made negative. It's because the one more question we are going to discuss. See, when electrons, so all the electrons are along with a positive ion, isn't it? If you take a metal, metal can be considered as a positive ion, large number of positive ion and electron. Correct? Am I correct? Free electron. So now when electrons are coming out, suppose if you consider this electron, some electron on the surface will have maximum kinetic energy because they don't undergo any collision. Whereas when the light is incident on an electron here, it may undergo many number of collisions. Suppose electron is here, which is very much inside. So some electron may undergo collision. So the photon energy is absorbed by the electron. See, the basic elementary process involved in photoelectric emission is the electron absorb a quantum, one electron absorb one quantum of energy and it is emitted. So certain minimum energy is required for the electron to come to the surface. Rest of the energy is emitted as kinetic energy. Okay. So kinetic energy available to the electron depends on how it is traveling inside the metal. The electron may undergo frequent collision. Some electron may just get ejected if they are on the surface. So all the electron coming out of the metal surface in photoelectric emission are not having the same energy. This point you have to make them understand. Am I making it clear? That is why you have the variation here. You have the, see, though I am applying negative potential, see, instead of positive, I am making it as negative for this part. Okay, it attains saturation because, why it is attaining saturation? Why it is attaining saturation? I would have given this example here. See here.
All photoelectrons are collected by the collected plate.
Collector plate. See here, suppose 1000 electrons are coming. 1000 electrons are for a given intensity. Intensity is constant and 1000 electrons are ejected per second. Okay. At 50 volts, 100 electrons because voltage is less. 100 electrons go to the anode. At 100 volts, 500 electrons. At 200 volts, 1000 electrons. At 250 volt, what will happen? Only 1000 electron, no? Because available electron itself is 1000. Isn't it? That is why it attains saturation. So all the available electron, as Anuja said, all the available electron get attracted. So increasing the potential is not going to change. That is why you get this graph. Increasing the positive potential will not change the photoelectric current. But now see the negative when you are at when I'm making this minus 50, 100 electrons reach, let us say 100 minus 50 volts, some 100 electron are reaching. Minus 60 now less number because the electrons are experiencing repulsive force. So as I'm increasing the negative potential applied to the collector plate, less number of electrons. So do you think this 30 electron has more energy than this 100 electron? Do you think? At 50 electron, 100 electrons are going to the thing, no? Which is having more kinetic energy? At 50, 30, very good, 30. Because even though 30 electrons, because this 30 electrons are able to overcome the retarding potential. Very good answer. This 30 electrons have kinetic energy more than the electron which reached the collector plate at minus 50 volts. At see, as you are increasing the negative potential, let us say at minus 150 volts, the electron, no electron reach. Okay. So this minus 150 volt is able to repel the most energetic electron. So what will be the kinetic energy of the maximum kinetic energy of the electron? If at 150 volt, precisely at 150 volts, no electron reaches the collector plate. What is the maximum kinetic energy? At 150 volt. At 150 volt, 0 electron. At 160 volt, what will happen? Minus 160 volt. 0. 0 only, no?
Yes,
so,
ma'am.
0 only. So, at the minimum negative potential of the collector plate, at which photoelectric current 0 is known as stopping potential. At stopping potential is able to stop the most kinetic, most energetic electron. So, the maximum kinetic energy is EV naught. In this case, it will be 150 volt. EV, 150 EV. Maximum kinetic energy will be 150 EV. So understanding the graph is very important. Now, once these two graphs are clear, now other graph will be very, very clear. So now listen here. Now I'm changing the intensity. For 2 intensity, I'm not changing the frequency of incident light. So now saturation current is changing. That means what? If I'm increasing the intensity now, number of photoelectron emitted changes. So say saturation current also change. So intensity control what? Intensity control number of photoelectrons. Intensity controls number of photoelectrons. But you see, for both the intensity, if you don't change the frequency of incident light, which is same. Which is same here. Stopping potential is the same. So now, stopping potential refers to energy of the, it is related to energy of the electron. So energy of the electron in turn is related to energy of light, isn't it? More energy light, more kinetic energy. So energy of light does not depend on, energy of electron does not depend on intensity. That means energy of light does not depend on intensity of light. It depends only on the frequency of light. It's another conclusion. Now in this graph, what is the variation? So this is another same graph. More graph is missing. Yeah. So now what happened? Now I'm not changing the intensity, but I'm changing the frequency. Intensity of light is constant. So saturation current is constant. So as the frequency of light increases, what happens? Retarding potential or the stopping potential increases. So stopping potential increases now, kinetic energy of the electron also increases. So kinetic energy of the electron is a function of frequency. So kinetic energy maximum is directly proportional to frequency. So when the electron kinetic energy increases with frequency, it is understood that light energy also will increase with frequency. So now you know that we plot the graph. So now from this graph, nu1, nu2, nu3 we know, corresponding stopping potential value we know. So you just plot the frequency, you are getting the straight line. So when we get the plot 1, 2, 3, we are getting nu1 for nu1, for nu2, for nu3. So I will get the graph. This blue line graph only I will get now. I will get it experimentally. If I plot the graph now, I will get the blue line graph. Just extend the graph to the frequency axis. So what happens now? As you are extending, as frequency decreases, what happens? The stopping potential also decreases. So this will be mu naught. So at nu naught, the stopping potential is 0. At nu naught, stopping potential is 0. That means what? What does it nu naught refers to? So nu less than nu naught, for all value of frequency less than nu naught, the stopping potential is 0. Stopping potential 0 na, electrons are not emitted. Correct? Am I correct? Stopping potential 0 na, there are no electrons to stop the electron. Correct? So now we get the significance of this threshold frequency. So it is the minimum frequency of the incident light at which photoelectrons come out of the metal surface. Less than the frequency of the incident light, no photoelectrons will be ejected, because stopping potential for all this frequency, up to this frequency, it is 0. Suppose a frequency, let us say it is 6 into 10 power 11 hertz. Nu naught is 6 into 10 power 11 hertz. If the frequency is less than that, these values, no less than this value, no photoelectrons will be emitted. So the minimum value of frequency of incident radiation below which the photoelectric emission stops altogether is known as threshold frequency. Okay. So we know that all these are the laws of photoelectric emission. So for a given photosensitive material, what are the conclusion? We know that even though if the intensity of incident light is very high, if the frequency of incident light is lower than the threshold frequency, photoelectric emission is not possible. Okay, so existence of threshold frequency. Then number of photoelectron or photoelectric current depends only on the intensity. The saturation current is directly proportional to intensity. Okay, and one more thing what we observed is, above the threshold frequency, as you increase the frequency of incident light, what happens? As you increase the frequency of incident light, what is happening? As the frequency increases, what increases? What is increasing? Stopping potential increases, isn't it? So stopping potential increases means what? The kinetic energy of electron also increases. So increases. Stopping potential is a measure of kinetic energy. Kinetic energy, maximum kinetic energy. So the energy of photoelectron, the maximum kinetic energy of photoelectron depends only on what? Frequency of incident radiation. Very good. It is independent of intensity. And photoelectric emission is instantaneous process. There is no time lag. There is no time lag. So now, why wave theory? So actually, when photoelectric effect was discovered, only wave theory was prevailing. Using that wave theory, the light traveling as a wave, they could not explain the photoelectric effect. Okay. What are the features of wave theory which could not explain? What are the features of photoelectric effect which could not be explained on the basis of wave theory? So according to wave theory, we can take a separate slide here. See, first point is, according to wave theory, the energy of a wave depends on what? Depends on intensity, isn't it? Energy depends on intensity. But here, so very high intense beam should bring photoelectric emission, isn't it? Very high intense beam. So the existence of threshold frequency should not come here at all. So if the wave has sufficient intensity, it should be capable of ejecting electron from a metal surface. But we know that however high the intensity is, if the frequency of incident light is less than the threshold frequency, no photoelectrons are ejected, isn't it? So this wave theory, no matter what the frequency of incident radiation, a light of sufficient intensity should be able to impart enough energy to eject electron. So the wave theory fails to explain the existence of threshold frequency. First point. Now, so higher the intensity, okay, higher the intensity, the wave energy is also will be more. So electron should come. As intensity increases, the electron should be ejected with greater kinetic energy, according to wave theory, because we know that the intensity determines the energy in the case of wave. But what was experimentally observed? What was experimentally observed? So electrons are expected to have higher maximum kinetic energy when light of higher intensity is illuminated. But do we get from this graph? I'm changing the intensity here. See here, I'm changing the intensity. I'm changing the intensity here. Okay, but the stopping potential same only, no? Stopping potential same now. Kinetic energy of the electron is same only, no?
Same.
Same. When I don't change the frequency here at all. I don't change the frequency. Intensity is changing. So according to wave theory, if intensity is changing, the energy of the electron should increase. So stopping potential also should change. But experimentally, what is observed is for all the intensity, as long as I don't change the frequency, stopping potential is not changing. So that proves that energy of the electron is independent of intensity of light. So this is a failure of wave theory. Wave theory could not explain this. Okay. So now, see, when wave is incident on a metal surface, okay, so the energy of the wavefront is spread over the entire wave, So sufficiently long time is required, long exposure time is required for the electron. See, energy available per electron will be very less because this entire wavefront, the energy is distributed over the entire wave. So when the entire wavefront is incident on a metal surface, the energy available per electron become very less. So the sufficiently long exposure time is required for the electron to come out. Okay, but each electron intercepts insignificantly small amount of energy because energy is spread over the surface of the wave. But what is observed is as soon as light is incident on the surface, immediately there is no time delay at all. So the instantaneous process of photoelectric effect was also not explained. Okay, so wave theory could not explain the independence of energy of electron with intensity. Okay, and existence of threshold frequency, and there is no time delay. So these three factors could not be explained on the basis of wave theory. Okay, so now we have to explain. So Einstein took all the experimental data and then combined the Planck's idea of what? Quantum theory of light, isn't it? Energy is emitted in the form of quantum of energy.
Photon.
Yes. So what are the main feature of photoelectric emission? It is an interaction. It is an interaction between the photon. It is interaction between a photon and an electron. Actually, it is a collision between an incident photon and an electron. Okay. So the free electron, no, the electrons are not very free. They are bound to the metal surface. So certain amount of minimum energy is required for the metal to come to the surface. So if h nu is the incident radiation, so minimum energy phi naught is the work function plus
kinetic energy.
Maximum kinetic energy. Okay. So this phi naught is h nu naught. So this is the basic one-line equation based on which all the experimental feature of photoelectric effect can be explained. Okay. So how are we going to explain the this one? So h nu is equal to phi naught plus kinetic energy maximum. Kinetic energy maximum is equal to h nu minus phi naught. So we call this as work function. So now let us take the existence of threshold frequency that we have to explain. How will you prove the existence of the threshold frequency? So this I can write it as h nu minus h nu naught. Suppose this is the incident energy. If frequency is less than nu naught, what will happen? This kinetic energy maximum will become negative, correct? Kinetic energy cannot be negative, no? Kinetic energy becoming negative now, no photoelectric emission is possible, correct? Am I correct?
Yes, ma'am. Yes, correct.
So that is a first experimental fact, no? If frequency of incident light is less than threshold frequency, kinetic energy become negative, so no photoelectric emission is possible. This is the first case. So now the energy of the electron, this is energy of the electron, this is energy of the light. So energy of the electron, the maximum kinetic energy of the electron is directly proportional to frequency. Was this observed experimentally? As we increase the frequency, this EV naught, kinetic energy maximum is EV naught. As frequency increased, the stopping potential also increases. Correct? This is a constant for a metal surface. Okay. So when nu increases, as frequency increases, V naught also increased. So kinetic energy of the photoelectron depends on frequency. This was also observed experimentally. Is there any term with intensity? No. So kinetic energy is independent of intensity. So what is the first statement is, it is a, elementary process involved in photoelectric emission. What is the basic elementary process involved in photoelectric emission? What is the basic elementary process? This question was asked as a board question. Elementary process is interaction between a single photon and an electron. This is a basic elementary process. A single photon eject one photon eject one electron. One photon eject one electron. Two photon eject two electron and so on. So n photon eject n electron. So as number of photon increases, number of photon is related to intensity, isn't it? Number of photon ejected per second per unit area. So as intensity of photon increases, number of electron also increases. So photoelectric current also increases. So these three observed features of photoelectric effect beautifully explained by one-line formula of Einstein. That is, kinetic energy maximum is equal to h nu minus phi naught. One is existence of threshold frequency. If nu is less than nu naught, kinetic energy become negative. So photoelectric emission is not possible. Above threshold frequency, when nu is greater than nu naught, the kinetic energy of photoelectron is directly proportional to frequency, and it is independent of what? Kinetic energy is independent of what physical quantity? Intensity. And it is a instantaneous process because it is a one photon eject one electron. So the entire energy of the photon is transferred to the electron. So electron takes some minimum energy to come to the metal surface, and rest of the energy is ejected as comes out as kinetic energy. Now all the electrons are not emitted with the same kinetic energy. Why? So the incident h nu, some electron, yes,
inside the metal, some at the boundary.
Some are inside, so they will undergo, before coming out, they will undergo frequent collision. And some electron are tightly bound, they are loosely bound. So though the metal surface is the same, all the electrons don't come out of the loosely bound electron will come out with the maximum energy.
Maximum kinetic energy.
Maximum energy. Loosely bound electron will come out with the maximum energy. So this one, of course, when you plot a graph between frequency. Yeah. So this expression also you should, how Planck's constant can be determined. So kinetic energy maximum is h nu minus W naught. W naught is a constant work function for a metal surface. So, and kinetic energy maximum is EV naught. So we get V naught. If you plot a graph between V naught and frequency, you get a graph like this. We already discussed. So slope of the graph, you compare with y is equal to mx plus c. Y is plotted along, stopping potential along y-axis and frequency along x-axis. So you get a straight line. So according to the equation, if you compare this, y is equal to mx plus c, it's a straight line, and V naught is equal to this. What is the slope of the graph?
H by E.
H by E. So actually Millikan wanted to disprove Einstein photoelectric effect. So actually he tried experiment with different alkali metal, and instead of disproving it, he was able to find the work function of different metal. How did you find the work function? So he was able to see when you extrapolate the graph. Actually with the experimental value, you will get a graph like this. Correct? You will get a graph like this. This is V naught and this is nu. So he extrapolated, extended the graph. So this value is nu naught. Just threshold frequency, isn't it? So h nu naught he was able to find out. So work function of different metals he was able to find out. So this way. So characteristic properties of photon. What are the characteristic properties of photon that explain the photoelectric effect? So now photon, no, we now accept that light behave like a wave, light also behave like a particle. When does light behave like a particle?
Interact with matter.
When it is interacting with matter. When it is interacting with matter. So light is interacting with the metal surface. Metal surface has lot of atom as matter. So radiation behave as if it is made up of particle. Each photon has energy h nu and momentum h by lambda. H by lambda, no, this is h by h nu by c. All photons of light of particular frequency have the same energy. It's okay. Photons are neutral. And total energy and any photon particle interaction in a photoelectric effect, energy and momentum are conserved. Will number of photon be conserved? Number of photon need not be, no. Photon, number of photon means number of energy quanta. So energy will be absorbed by the new photon. Energy may be absorbed by the electron and it will be radiated. Is it clear? Photon may be converted into energy. So as intensity of light increases, increase in the number of photon. Intensity is referred to number of energy quanta emitted per second per unit area. So intensity of light increase, number of photons increases. So the stopping potential in an experiment on photoelectric effect is 1.5 volt. What is the maximum kinetic energy?
Potential is directly proportional to the maximum kinetic energy.
So it is EV naught. Maximum kinetic energy is EV naught. So if the stopping potential is 1.5 volt, the maximum kinetic energy will be 1.5 electron volt. That's all. Electron volt is an unit of energy. Show graphically the variation of de Broglie wavelength with the potential through which an electron is accelerated. So when we talk about de Broglie wavelength, we say lambda is equal to h by p. So you have different formula for this, isn't it? What are the different formula? So p is Ke. So p is root of 2m k. So lambda is also h by root of 2m k. So any charge accelerated to the potential V will acquire kinetic energy. So lambda formula also will be this. So please make the children aware of these three formula. So what will be the graph? The variation of de Broglie wavelength with potential. So lambda is inversely proportional to root V. So V versus lambda would be a curve. Be a curve. Be a straight. A proton, and these are all very familiar problem. A proton and electron have the same kinetic energy. Which one has greater de Broglie wavelength? So we know that lambda is h by root of 2m k, 2me. This just now we derived. So lambda is inversely proportional to m. So electron will have greater de Broglie wavelength. It's very simple, isn't it?
Yes.
Same question here. Show on a plot the nature of variation of photoelectric current with intensity. So see that you are making the children repeatedly learn this graph. So in photoelectric effect, graph related questions are very, very important. I think Anuja madam has sent this, isn't it?
Yes, ma'am.
So figure shows a plot of 1 by root p versus lambda, de Broglie wavelength, and 1 by v for two particles A and B. Which line represent particle of larger mass? So we know that lambda is equal to h by root of 2m qv. Okay, so if I bring this side, I will get lambda into root p is equal to what?
H divided by root of 2m.
2mq. So I can divide this lambda by 1 by root v I can write. Okay. So what is slope of the graph here? 1 by root v by lambda. So what is 1 by root v by lambda? Root of 2mq by h. So slope here, slope is directly proportional to m. Slope is more now, mass will be more. Is it correct?
Yes, ma'am.
V is having smaller slope here. 1 by root v by lambda by, so lambda is equal to h by root of 2mqv. So lambda into root v is equal to h by this. So lambda by 1 by root v is h by this. So I am taking the reciprocal. 1 by root v by lambda, that is the slope of the graph, is directly proportional to m. So A will represent larger mass. Correct? Am I correct?
Yes, ma'am.
Yes. Slope of the graph is directly proportional to m. So A represent larger mass. Larger mass.
Yes.
Find the ratio of de Broglie wavelength associated with two electron accelerated through 25 volt and 36 volt. This exam, compartment exam, this was asked. So lambda is inversely proportional to root v.
Root v.
Lambda 1 by lambda 2 is root of v2 by v1. So 65. Easy question. Now, the graph shows a variation of stopping potential with frequency of incident radiation. So stopping potential with frequency. Please ask the students to just see what is represented on y-axis and x-axis. So which one of the two has higher value of work function? B or A? A, no? A. Because nu naught dash is greater than nu naught. And h nu naught dash will be work function is h nu naught. Okay. Justify your answer. So greater the threshold frequency, greater is the work function.
Yes, ma'am.
Threshold frequency for metal A is more. So metal A, threshold frequency for, threshold frequency is more, work function is more.
More.
Metal A is more. An alpha particle and a proton are accelerated from rest by the same potential. Find the ratio of the de Broglie wavelength. So it's very easy.
Ma'am, some
Alpha,
disturbance is coming.
yes.
Yes.
So lambda is h by root of 2mqv. So proton and alpha. See, children, make the children understand the mass of proton. Mass of alpha particle is 4 times mass of proton. 4 times mass of proton. Okay. And charge of alpha particle is 2 times charge of proton. So lambda alpha by lambda p will be inversely related. So 1 by 2. Qp by q alpha is 1 by 2. Mp by m alpha is 1 by 4. So it is 1 by 2 root 2. So right, this is a frequent, very, very important. See, this exam, I think more of theory question you can expect. 3-mark question if they ask now in this lesson. You can expect this type of question. Write Einstein photoelectric equation. State clearly 3 salient features observed in photoelectric effect, which can be explained on the basis of the above equation. So you will let the children write the equation correctly and explain what is phi naught, what is h nu. H nu is the incident light energy. Phi naught is a work function. So let them write. So how will they proceed with the answer? First one is
incident energy of photon. It's split into work function and the kinetic energy of.
Yes. So when light, first the child should be able to explain the photoelectric effect. So when light is incident on a metal surface, minimum energy required. H nu naught is a minimum energy.
Escape the electron from the metal surface.
And the rest appear as kinetic energy.
Kinetic energy.
Okay. So now when nu is less than nu naught, kinetic energy become negative.
Negative.
So no photo emission
photoelectric.
take place. No photo emission possible. So when nu is greater than nu naught, suppose nu is, see, H nu naught is a constant, isn't it, for a metal surface. So as you increase the energy of the incident light, what will happen? Kinetic energy maximum will increase. So maximum kinetic energy of the electron increases with increase in frequency. Okay, that's why stopping potential increases with increase in frequency. What is measurable? I cannot measure the velocity of the electron and calculate kinetic energy, no? Can I? But I can measure stopping potential. So if I measure the stopping potential, what is observed is as I increase the frequency, kinetic energy also increases. So kinetic energy is proportional to frequency. This is the second observation. So first one is existence of threshold frequency. Above threshold frequency, kinetic energy is proportional to frequency. Okay. And here, as number of photon increases, number of electron also increase, because according to Einstein, the one photon eject one electron. One photon eject one electron. As number of photon increases means intensity increases. As intensity of incident light increases, number of photoelectron increases. So photoelectric current increase. That is a third observation. And photoelectric current is a instantaneous, photoelectric effect is an instantaneous process, because it is a interaction between, it is the basic elementary process. What is the basic elementary process?
Photon is interact
absorption.
With the one
Single absorption of the same word is given in the reader. Absorption of single photon by a
single electron.
And emission. This is the instantaneous process. The basic elementary process is absorption of single photon by a single electron and then getting emitted. This is the instantaneous process. So this is repeatedly asked. Maybe you'll come across different type of question asked very, very differently, but the answer will be the same. So plot a graph showing the variation of stopping potential with the frequency of incident light radiation for two photosensitive material. Function W1 and W2. W1 greater than W2. So what is the stopping potential with frequency? This is V0 and this is frequency. So you will get a graph like this. W1 greater than W2. So can I write this as 1 and this is 2? Am I correct?
This is correct? 1.
Yeah. This is 2, this is 1. Because it is given W1 greater than W2. So nu naught 1, this will be nu naught 1, nu naught 2. So threshold frequency for the metal 1 should be more. Slope depend on what? What is the slope of the graph?
H by E.
H by E. Intercept?
W naught by E.
W naught by E.
Minus W naught by E.
Minus sign, because negative graph. Because I will get V naught as H by E nu minus H by E mu naught. This is the equation. So this will be the slope. H by E will be the slope. And this full will be the C, that intercept. H nu naught constant. Is W naught. Describe briefly 3 experimentally observed features in the photoelectric effect. So what are the experimental features of photoelectric effect? For a given photosensitive material and frequency of incident radiation, the photoelectric current is directly proportional to intensity. Isn't it? That is a experiment. Photoelectric current is directly proportional to intensity. Yeah. Then for a given photosensitive materials and frequency, saturation current is found to be proportional intensity Whereas stopping potential is independent of intensity. Correct?
Yes,
Stopping potential depends only on the frequency.
frequency.
For a given photosensitive material, there exists a certain minimum cutoff frequency of incident radiation. So existence of threshold frequency. So when you increase the frequency of light above the threshold frequency, stopping potential increases. So when stopping potential increases, maximum kinetic energy of the electron also increases.
This is
These
the
are
laws of photoelectric effect.
These are laws of photoelectric
laws
effect,
of
but it is not
photoelectric
asked
effect.
as laws, isn't
Yes,
it?
ma'am.
So
Yes,
you should teach the children how different ways of asking the same question. You teach all the experiment, no?
Yes,
You teach all the experiment, isn't it?
Yes,
Intensity, if you increase the intensity,
Yes.
photoelectric current increases. If I increase, so saturation current is directly proportional to intensity. If I increase the frequency, stopping potential increases. What is the inference? Maximum kinetic energy of the electron increases. But stopping potential is independent of intensity. That means energy of electron is independent of intensity. It depends only on the frequency. Okay. And the photoelectric emission is an instantaneous process. Okay. Even see here, even a dim light can bring photoelectric emission. But a strong beam of light will not bring photoelectric emission if the frequency is less than threshold frequency.
Less than threshold frequency.
Yes. A proton and neutron are accelerated through same accelerating potential. Which one of the two has greater value of de Broglie wavelength and less momentum? What do you say? Accelerating potential is same for them. So lambda is equal to h by root of 2m qv. This is a formula. Potential is the same. So lambda p and lambda t is equal to, what is the ratio? Root of md by mp. Correct? Am I correct? Because the charge of proton and neutron is the same. So it is root 2. Am I correct?
Yes.
Root 2. So which will have less momentum? Which will have less momentum? Neutron or proton? Charge being the same, lambda, this one is inversely proportional to root m, no? Lambda is inversely proportional to root m. So mass of neutron being larger, wavelength, de Broglie wavelength for neutron will be less than that of what? Lambda
Neutron.
t, yeah, lambda t will be less than lambda p. But what is momentum?
Lambda is equal to h by
Momentum
p.
of, yeah, lambda is equal
Lambda
to
is
h
equal
by
to h by p.
p. So p is h by lambda. Correct?
Inversely proportional.
Inversely
Yes, ma'am.
proportional to. Momentum is inversely proportional lambda. So momentum of neutron will be more than momentum of proton. Correct?
Yes, ma'am. Yes.
So this is actually, here we are bringing in two concepts. Okay, easy question only. It's easy question. Okay, ma? So the type of question are all the question I'm discussing are previous year board question. So proton will have less momentum. That's what we proved up. Proton will have less momentum. Lambda d here is
Lambda d greater.
lambda d is less, no?
Lambda d is less. So BD is greater.
Lambda d is less than lambda p, no, according to this. Because mass of neutron is more. Lambda d is, so lambda p will have less momentum.
So here
Correct,
we
sorry,
have to
proton
change
will
the
have
sign.
less momentum.
Here we
Proton will have less momentum. That's what we discussed, isn't it? Proton will have less momentum. Correct. So lambda proton is greater than lambda d. So momentum of proton will be less than
momentum of neutron.
And this is also often asked question. Monochrome monochromatic light of frequency 6 into 10 power 14 hertz is produced by a laser, the power emitted is 2 into 10 power minus 3. The power is 2 into 10 power minus 3 watt. Estimate the number of, how will you calculate the number of photons emitted per second? So, power, see actually power is equal to total energy by time. This total energy is due to what? N number of photons. Energy is equal to h nu. So total energy is n h nu by t. Okay, this is a formula. So number of photon per second. So what is n by t? This only asked. That is power by energy of each photon. P by h nu is equal to number of photon per second. So P by E. P by E. This is a formula. Okay. So here number of photon emitted per second. Let the children remember that it is power by energy of each photon. So power is, so number of photon emitted per second will be 2 into 10 power minus 3 divided by energy of one photon. So that is 6.6 into 10 power minus 34 into nu. 6 into 10 power 14. We have to calculate. This will be the number of photon. Draw a plot showing the variation of photoelectric current versus incident radiation on given photosensitive surface. That's very easy. Two monochromatic radiation of frequency nu1 and nu2 and having the same intensity are in turn incident on a photosensitive surface. Explain giving reason in which case more number of electrons will be emitted. Will there be any change in the number of electron emitted? If they have the same intensity?
No. Intensity is directly proportional. No. No.
No, because intensity is the same.
Intensity.
Maximum kinetic energy. For which
Directly
case max?
V1.
V1. Nu1. For nu1
Yes,
maximum because frequency is more. Kinetic energy.
Kinetic energy is the most.
Okay. See, these questions are very easy, but students should not miss. Why photoelectric current cannot be explained on the basis of wave theory? Give reason. We discussed, no? Write the basic feature of photon picture of electromagnetic radiation on which Einstein photoelectric equation is based. So you should write about basic feature of photo. These are the basic feature. The basic feature of photon picture of EM radiation. You should give the property of photon. That's all. So what is photon picture? Light is composed of discrete packet of energy called quanta of photon. Each photon carries energy is equal to h nu. Energy of photon depends only on its frequency. That has to be specified. Energy of photon depends only on its frequency and not on intensity. And photoelectric emission occurs due to absorption of a photon by an electron. Okay, these are the basic features.
Yes,
so now, how wave theory could not explain. So there are three features you can write. The maximum kinetic energy of emitted electron should be directly proportional to intensity according to wave theory, but it is not observed experimentally. According to experiment, maximum kinetic energy of the emitted electron depend only on what? Incident frequency. So according to wave theory, the maximum kinetic energy should depend on intensity. But what is observed is maximum kinetic energy depend on frequency. According to wave theory, threshold frequency should not exist. Light of all frequencies should emit electron provided intensity is high, isn't it? So existence of threshold frequency was not explained. The maximum kinetic energy of photoelectron should depend on intensity according to wave theory. But according to experiment fact, maximum kinetic energy depend on frequency. And according to wave theory, photoelectric should not be instantaneous process because energy of wave cannot be transferred to particular electron, but will be distributed to all the electron, and so it will take more time for the ejection of electron. But according to experimentally observed fact, there is no time lag, isn't it? So please, I will please tell the children that, see in the textbook, one book, a big 2 paragraphs are given, isn't it? Let you just give the minimum point. Minimum number of lines to be learned by the students. Only the basic points. If they see too many concepts, they will get confused. Let them write only these 3 points. The essence of that children should know. So again, repeatedly they will ask de Broglie wavelength. This type of question will be asked. A proton and alpha particle have the same de Broglie wavelength. They determine the ratio of their accelerating potential, their speed. Speed can be easily found out, isn't it? 2 different formula they have to use. What is the formula for the first one? Lambda p is equal to lambda alpha. Correct? So h by root of 2 mp qp. Accelerating potential is Vp is equal to h by 2 m alpha q alpha v alpha. V alpha, we have to find the ratio of their accelerating potential. So what is V alpha by Vp? What is V alpha by Vp? Root of mp qp by, are you having the answer ready? This mp by m alpha is 1 by 4 and this is 1 by 2. So V alpha by Vp will be what? 1 by root 8. Correct? Am I correct? Yes or no? Participants, please tell me. Gracie ma'am, is it okay? Hello, am I audible?
Yes, ma'am. Yes, ma'am.
Yeah.
Ma'am, yes.
Yeah.
Sorry.
So a proton and alpha particle have the same de Broglie wavelength. So lambda p is equal to lambda alpha. Determine the ratio of their accelerating potential. So write lambda p is equal to lambda alpha and V alpha by Vp, where V alpha and Vp represent the accelerating potential. So I'm getting 1 by root 8. So what is the ratio of their speed? So shall I use, see, when for speed you should write lambda p in terms of speed, no? What is that? What shall I do? Huh? H by mv I can use, no? H by m alpha v alpha. So what is the ratio of their speed? What is this? Am I correct? This is the ratio of their speed, not potential. Correct? Yes. Can I continue?
Yes, ma'am.
Because
Yes, ma'am.
H by
Yes, ma'am.
P. Yeah, yes. Okay. Yes. Can you mute teacher? I want everyone to mute your audio, please. Some disturbance is there in one of the mic, I feel. Yeah, thank you. So X-ray fall on a photosensitive surface to cause photoelectric emission. Assuming that work function of the surface can be neglected, find the relation between de Broglie wavelength of electron emitted to the energy of the incident photon. So we are going to put phi naught as 0. Correct? X-ray is falling. So any radiation can cause photoelectric emission. Depends on the surface. Some surface require X-ray to emit. Though if the work function is more, high energy photons are required. So you have to find the relation between lambda of electron and the incident photon energy versus h nu. Okay, so now you know that E energy, incident energy is equal to K maximum because phi naught is 0. So that is energy h nu. Okay, de Broglie wavelength. So kinetic energy maximum is P square by 2m. This is P square by 2m. And this one is
HC by lambda.
HC by lambda. hc by lambda.
Inversely proportional to
Yeah.
lambda.
So P will be root of 2me. This is the momentum of the electron. Okay, this is the momentum of the electron. So de Broglie wavelength of the electron will be h by root of 2me. Don't write E as hc by lambda. Let it be E only. Let it be E. So we have to find out only de Broglie wavelength of electron. No, so h by root of 2me. So draw the graph of x as a function of, for x as a function of lambda energy. And you have to draw a graph of lambda and E, so you will get an inverse relation. Again, this is a repeat question, right? 3 basic properties of photon which are used to obtain Einstein photoelectric equation. Use this equation to draw a plot of maximum kinetic energy of photoelectron emitted versus frequency. So this one, first part clear. So here h nu is equal to h nu naught plus Ke maximum. So you have to plot a graph between plot of maximum kinetic energy versus frequency. So again the graph will be like this. This should be y-axis, this kinetic energy maximum versus frequency. So frequency will be nu naught plus kinetic energy maximum. The slope will be kinetic energy maximum by h. Even a graph is going to be like this.
Straight line.
Straight line. So
Like
previously we
Photon.
plotted for V naught versus mu. Slightly different. Use this equation to draw plot of maximum energy or taking maximum energy here. Or EV naught itself is taken. Kinetic energy or kinetic energy maximum is what? EV naught. Is it not? EV naught by mu. Using the graph shown in the figure for stopping potential versus the incident frequency of photon, calculate the Planck constant. So using this data, you should calculate the Planck's constant. So slope of the graph gives what? So h by E is something like 1.23 divided by, I'm getting 5 here. Sorry. Slope of the graph is this 5 into 10 power 8 minus 5. Isn't it? This is 8 and this one is 5. So the 1.23 divided by what is that? 8 minus 5. 3 into 10 power 14.
10 power 14 hits.
40. So h will be 1.23 by 3
Divided by 3
into 10 power 14 into 1.6
into
into 10 power minus
minus 19
19. Correct?
joule second. Yes, ma'am.
Yeah. So I will get. So this will be 0.41, isn't it? 0.41 into 1.6 into 10 power minus 33. Maybe I'm getting this as 1.6 points.
6 into 10
10
power
power
minus
minus 34 joule second. I
joule
will
second.
get. I will get. This already we have done. Calculate the de Broglie wavelength of electron orbiting in n is equal to 2 state. So n is equal to 2 state of hydrogen. See, this is only hot question because we are combining concept from atoms and then we are combining concept in de Broglie wavelength. So when two concepts are intermixed, it becomes a hot question. Okay. So En is 3.14, 3.4, isn't it? E2 is 3.4 and de Broglie wavelength. The energy, see, this is the energy of electron. This is the total energy of electron in n is equal to 2 state. What is the de Broglie wavelength? So after finding this, you substitute here. So lambda is h by root of 2m ek. So total energy, no? Need not be kinetic energy, maximum energy of the electron. So this is a total energy, ek. So total energy is this much. The work function of a metal x equal to this much. Calculate the number of photon of light of wavelength this much, whose total energy equals W. Energy is W. So energy of the thing is this much. 3 into 10 power minus 5. So work function is n into h nu. Okay, work function. See, the work function of the metal is this much. Calculate the number of photon of light, which is having the energy which is equal to work function of the metal. So work function is the energy of the photon is energy due to n number of photon, that is equal to this value. This is equal to 3 into 10 power minus 19. From this, calculate n. So 3 into 10 power minus 19 into hc by lambda. hc by lambda. This is n, number of photon. So from this we can calculate. Okay. So there are different ways of asking the question. So the kinetic energy of a beam of photon, electron accelerated through potential B equals energy of photon of wavelength 5460. So we are to equate both. So kinetic energy of electron is this much. Okay, the kinetic energy of electron is equal to the energy of photon of wavelength 5460. Find the de Broglie wavelength. So energy of the photon is this much, hc by lambda. And you know that. So de Broglie wavelength is h by root of 2mk. What is k here? Kinetic energy is equal to h nu, or this is hc by lambda. Lambda of what? Lambda of photon here. This is lambda of electron. So what is lambda of electron? Lambda of electron will be h by root of 2m hc by, am I correct? Check what I'm doing.
Yes.
Correct, huh?
Yes.
So in the root, so here, this if I take it as root h divided by
The root h will cancel.
root h will get cancelled, root h, and the lambda will go up, correct? Root 2 mc, this will go up. So this will be cancelled, so I will get this. Lambda also will be inside the root.
Root lambda.
So lambda of the particle will be root of h lambda by 2x. Please go through this problem because it was once asked in the board exam. This we can find out, isn't it? A proton and alpha particle are accelerated. So repeatedly these questions are asked. Please make the children learn. Where they go wrong is they don't know what is the ratio of MP by M alpha, QP by Q alpha. So you tell them mass of alpha particle is 4 times mass of proton. Charge of alpha particle is 2 times charge of proton. This, unless they know this, they will go wrong. So electrons are emitted from the cathode of a photocell of negligible work function. So immediately put h nu is equal to half mv square. Derive an expression for the de Broglie wavelength of electron emitted in terms of wavelength of incident light. So once you know kinetic energy is equal to h nu. Here this is lambda of what? What is this? This is lambda of incident. Photon. Very good. Photon. So here this is de Broglie wavelength of electron. So de Broglie wavelength of electron is h by mv. Substitute that here. Okay. You are getting lambda of de Broglie wavelength of electron is this much. That's what we did before.
Yes, ma'am.
Calculate the kinetic energy of electron having de Broglie wavelength of 1 Armstrong unit. So when, see, using the formula de Broglie wavelength, I can calculate the momentum. Correct? So momentum is h by lambda. If I know momentum na kinetic energy is p square by 2m. So P square is h square by lambda square into 2m. That's a formula. Okay.
Yes, ma'am.
State any two properties of photon for a monochromatic radiation incident on a photosensitive surface. Why do all photoelectrons not come out with the same energy? We discussed, isn't it?
Yes, ma'am.
Yeah. We can also go through this. A photon and a proton have the same de Broglie wavelength. Photon and proton. This is a
Proton.
material particle. It is a light particle. They have the same wavelength. Which has more total energy? So lambda 1 is equal to lambda 2. So energy of the photon is hc by lambda. Photon energy is what? hc by lambda. Correct? Energy of proton will be proton energy. P square by 2m. Because I need to write P in terms of de Broglie wavelength. This is lambda is the same. For both lambda is the same. Photon
H by
wavelength.
lambda.
H square
H
by
square by lambda
2
square.
lambda square m. So energy of photon divided by energy of proton will be what? hc by lambda divided by h square by 2 lambda square m. Okay, so I am getting this as this value. If you hc by lambda 2 mc lambda by h.
Yes.
So what do you conclude? Which has more total energy? So K1 by K2 is, this is not, is it less than 1 or more than 1? It's a positive quantity, no? So photon will be,
K1.
this is a positive value. 2 mc lambda
So
by h.
K1 by K2 is greater than 1.
K1 by K2. K1 is greater than K2. Because
K2.
K1 by K2 is greater than, this one is a positive
1.
one.
So K1 greater than K2.
So photon has more energy than proton.
Yes,
Okay.
ma'am.
Same way. Same thing. So again, repeat, see, please make the children learn this. Write Einstein photoelectric equation. For the equation itself, 1 mark will be given. State clearly how this equation is obtained using photon picture of electromagnetic radiation. So you have the child should explain. Okay. So if h nu is the incident radiation, minimum energy required for the electron to come to the surface is h nu naught, and rest of the energy appear as maximum. That's all. Right, 3 salient features observed in photoelectric effect which can be explained using this equation. Already we have discussed this.
Yes, ma'am.
Yeah. And this is photon picture of light. Something they will this one also we discussed. So threshold frequency. That's what the previous question. Kinetic energy maximum should be greater than 0 when nu is greater than nu naught. All this we have already discussed. So from this graph is given which of the metal has larger threshold wavelength. Again, it's a confusing. Which has larger threshold frequency?
X.
X has frequency. X frequency is more than
Y.
Y. Lambda X will be less than lambda Y. Because frequency and wavelength are different. They are inversely related. Frequency and, okay. Explain giving reason which metal give out electron having larger kinetic energy for the same wavelength of incident radiation. Suppose X and Y are two metal surface. So X has larger threshold, so Y has larger threshold frequency. Okay, which one will give electron having larger kinetic energy? X or Y? So kinetic energy X is equal to h nu minus phi naught X. Kinetic energy Y will be same, incident energy is same, phi naught Y. So what is it? See here, same energy is incident on X and Y. Which metal surface will emit kinetic energy of
Y.
electron? Y. Is it Y? Yes. Yes. Is it so? I don't think so. Why are you telling Y? How are you telling Y?
Work function.
Suppose h nu is 100, let us say 100. Okay. Phi naught X is 20 joules. Phi naught, I am giving the value now. Phi naught Y is 30 joule. Tell me, what is kinetic energy of X? Kinetic energy of X will be 100 minus 20. That is 80.
80.
What is kinetic energy of Y?
70.
70. Correct?
Yes,
So what is the answer now?
X.
Larger kinetic energy will be X, which is having lower work function, because less energy is required for the electron to come to the surface, isn't it?
Lower
Work function low, na higher kinetic energy. If the distance between the light source and metal X is halved, how will the kinetic energy of electron emitted from it change? Suppose if I change the distance, will it affect the kinetic energy? What will be affected? Huh? There is a metal surface here, metal surface, and this is a light source, let us say. It's a light source. Okay. If I am moving this light source away or towards, kinetic energy, will the kinetic energy be affected? So intensity of light is going to change. You know, if I move the metal source towards that away, source of light towards metal and away from the metal, what will be affected? Intensity only will be affected. Will the kinetic energy be affected? Number of electron emitted will change. The distance of the source
energy not change.
Not affected. How then I see? Suppose if I am using yellow light, I am now using blue light. I'm not changing the distance. Yellow, blue, like that I'm changing. Will the intensity of light is same? I'm using only 100 watt yellow bulb, 100 watt blue bulb. Will the intensity of will the current change? Will the photoelectric current change?
Intensity is same, current is also same.
Intensity change ana current change agum. Now intensity change pannala, color தான் change பண்றேன். Color change ஆனா என்ன change ஆகும்? Frequency change ஆகும்.
Frequency change ஆகும்.
So photoelectric current change ஆகாது. Whereas
the question will change.
Yeah, distance change ஆனா intensity change ஆகும். Light now I'm not changing the source of light. I'm using the same source. I'm only changing the distance. So intensity change ஆகும். So current தான் change ஆகும். Okay, kinetic energy will not change.
Not affected.
Will not change. So you are familiar with these type of graph now? So I1, I2, I3 represent different intensity. Nu1, Nu2, Nu3 frequency. Nu1, Nu2, Nu3. Point out two curves for which the incident radiation have the same frequency but different intensity. Which two curves have the same frequency? For A and B, stopping potential same la?
Yes, ma'am.
So stopping potential same na?
Frequency also
frequency is same. Intensity is different anyway. Okay. Electron and a photon have wavelength of 1.5. Find their momenta. So if you know the wavelength, you can find the momenta. So energy of the photon, kinetic energy of the electron. This you can use the formula. Kinetic energy of the electron is p square by 2m. Okay, energy of the photon is hc by lambda, h nu.